Do you remember the function rand_i? Rand_i. This was a built-in MATLAB function that took at least one input, and its input was the maximum integer that could be randomly generated. So, for example, if I wanted a random number between 1 and 6, which was used in several examples we did with rolling of dice, I could push enter and it would give me a random number between 1 and 6. Here would be 5. So I put rand_i 6, meaning 6 is the maximum integer, with 6 included. But what happens if I use this function incorrectly and say I put rand_i -2? So now this is supposed to be a random number between 1 and -2, where -2 is the maximum number I can get. So that doesn't really make much sense. Let's see what happens. I'll push enter. Okay, I get a red syntax error. It says error using Randy. First input must be a positive scalar integer value, Imax, or two integer values, Imin, Imax. Okay, so we're given an error message there. It says basically that we're using this function incorrectly. Okay. This function has checked the inputs, and based on what we gave it as an input, it decided to throw an error message at us. This is called input error checking and is the subject of this video. The idea behind input error checking is that we are going to make a function, any function, that requires inputs. Now the function will operate on these inputs and perform some sort of calculation and provide an output. However, what if the input that you receive, or the inputs, plural, that you receive, are not what you intended on receiving? And it really doesn't make much sense based on how you've written the function then. In this case, we want to throw an error. Tell the user, hey, you are not using my function as I thought you would when I coded it. Okay. Now, as is usually the case in programming, our function, our code, is a small piece of a larger program. Okay, so this rectangle symbolizes the larger program, and maybe our function is just a small piece of that guy. So remember that I'm using kind of this black box representation of a function where we get our inputs and then we produce an output. Okay, but maybe there's another function in this larger program, and we get our input. So this is our input, our function here. Maybe we get our input from the output of another function. And so there might be, depending on, maybe if this function was incorrect, first function, maybe there's an issue with the inputs that are coming into our function. And we want to check those inputs before we perform any calculation in our function. Let me give you an example. I'm going to go to New, Function, and I will call this guy Newton, my Newton. And the idea behind this function is I'm going to input a net force magnitude and a mass, and I will use Newton's second law to calculate the acceleration magnitude and output that. So in my Newton, first I'm going to delete the function's end because it's optional. And the output arguments will be just one, a mag. And the input arguments will be f mag and m, which is the mass. So I will write a description here, my Newton. Calculates the magnitude of acceleration experienced by mass m with net force magnitude f mag. I'll put my name there and the date. Applying Newton's second law here is very simple. Of course you know, or maybe you don't know, depending on where you're at in college or high school, but maybe you know that F equals ma, where this is the net force, this is the mass, and this is the acceleration. And if we're dealing in magnitudes, then it's also true that the magnitude of the net force equals mass times the magnitude of the acceleration. So we can calculate the magnitude of the acceleration by taking the magnitude of the force and dividing it by the mass. And that's our function as it is right now. That seems pretty simple. Let me save it. Okay. And it is simple. Let me clear the command window, clear the workspace. Suppose I had a net force, F, of 10 newtons and a mass of 2 kilograms. And I wanted to find the magnitude of the acceleration experienced by this object. So I could say A equals my Newton of F, comma, mass. And I get an answer of 5 meters per second squared. The idea behind this lesson is I want to check the inputs coming into my function to make sure they make sense and they are what I expect them to be. In this example, because I'm dealing with a net magnitude force, it doesn't make sense for that magnitude net force to be negative. So I would want to check to make sure it's not negative. Also, since I have a mass coming at me, I want to make sure that mass is positive, because it doesn't make sense to have a zero mass or a negative mass. Now, as it is, okay, let's suppose that I gave it a mass of 0. And you say, yeah, that should throw an error anyway. Why do we have to check the inputs coming at us? This is going to throw an error anyway. So we put a semicolon there. I will call my function, hit enter, and lo and behold, my function has not thrown any errors. MATLAB divided by 0 with no problem. Well, what's the catch there? Well, if you look at A, it says INF. A equals INF. The acceleration is INF. That stands for infinite. The point here is that MATLAB calculated it and did not throw me an error. But in this case, something is wrong, and I want my code to error. Perhaps the mass came from this function here, and this function was incorrect. I do not want to keep propagating that error to our function and then past our function. Maybe there's another function. I don't want to keep propagating that error through the entire code. I want to catch it. Say, nope, the mass is wrong. You can't have a mass of 0. That's got to be wrong. So I want my code to stop, error, and spit the user back a message. And it also turns out that if I give it a mass of, say, -2, my function will also calculate that acceleration. Because it doesn't know what we intended. It doesn't know that the magnitude of the acceleration has to be positive. It doesn't know that, so it just does the calculation. Okay. So let me clear the command window and let me clear the workspace. I'm going to go back up into my function. And I want to test the inputs coming at me. Okay, so the first thing I want to do is test the magnitude of the net force. Make sure it's not negative. So how do I do that? Well, I can use the error function in MATLAB. Error. Error is a built-in function, and when it's executed, it stops the code and it produces a message that you put in single quotes. So I want that message to be displayed if, keyword there, if the magnitude of the net force is negative. So first we have to test the magnitude of the net force. So we can use selection for that. If F mag is less than 0. If F mag is less than 0, now I want to execute the error command. So I'm going to type error, and then a parenthesis, and then a single quote, and then give the user a message. Maybe magnitude of net force must be non-negative. Non-negative. Notice there's a slight subtlety that I'm using between positive and non-negative. Positive means larger than 0. Non-negative includes 0. So it's okay to have a magnitude net force of 0. That's fine. So here we're checking that it's negative. Okay, so if I want to test for that, there's my error message inside the error function. And then I will hit enter and then push end, type end there to end my selection statement. So now if I receive a negative magnitude net force, then this if statement on line 6 will be true. And if it's true, it will execute everything between if and end, namely this error message here. We'll say error, magnitude of net force must be non-negative. And that error halts the code, it stops it completely. It gives control back to the user. Right, so let's test it out. Let me save it. So let me give it a force F equals -10 newtons. Mass equals 2 kilograms. and let me call my function a equals my Newton f comma mass. Hit enter, and there we go. It says error using my Newton, line 7. That's the error message. Magnitude of net force must be non-negative. I say, oh yeah. So I come back up here and I say, oh, I meant to put F equals 10. So that helps me catch the error. And now I change it, I call it again, and now I calculate just fine. In the case that F is positive, this line 6 statement is false. And so everything between if and n gets skipped. And then it comes down here to line 10, and it calculates a mag just fine. And then it outputs it back to me. Now, we have two inputs, so let's check the mass as well. So in this case, I want to throw an error if the mass is not positive. So if it's 0, or if it's negative, I need to throw an error. So I will say if m is less than or equal to 0, error, single quote, mass must be positive, single quote, end. Let me save that, and I will clear the command window, CLC, clear the workspace. Alright, so let me give it a force, F equals 10 newtons, mass equals 0 kilograms, and let me see how my function behaves now. In this case, hit enter, error, line 10, mass must be positive. I say, oh yeah, what was I thinking, putting a 0 mass in there? So then I go back and I look at what I really meant to do. Oh, I meant to put 0.2, and I forgot the 0.2, for example. And so then I fix it, and I give it a new mass, and then I get a new acceleration, and it goes through just fine. In this call, F was 10, so this if statement was false. So it skipped and it went down to line 9. This if statement now is false, so it skips that and comes down to line 12, and then goes to line 14, and it calculates a magnitude, and it outputs it back to me. Some things to keep in mind when you're input error checking. And we talked about the non-positive or non-negative versus positive. But you want to place the input error checking, at the top of your code. The top of your code there. Think about why that might be. Well, this particular example is very short, right? There's really just one line of code that we're executing beyond the error checks. But imagine you had some function that was quite lengthy. You don't want to perform all those calculations and take up the time, the run time we call that, calculating all these things, when in the end you're just going to throw an error anyway. So we put the checks at the very beginning as kind of a screening, right? You have to pass the screening in order for me to perform the calculations. So we put those right at the beginning of the code. Yeah, you passed the screening. Okay, so now we proceed. Another thing to keep in mind here is that the primary job of the input error check is to stop the code. Okay. It's nice that it displays a message to me, the user, but its primary job is to stop the code. Do not propagate this error further through my code, and then if my code goes to another piece of code, just stop it right there. And then a secondary job of the input error check is to display a red error message. Now in this example, we checked basically the sign of fmag and m. But depending on your application, it doesn't have to be the sign. You might check to see that something is an integer. You might check to see that something is odd or that something is even. You might check two vectors coming at you and make sure that they're the same length. Okay, so there are just an infinite number of checks that we may be asked to perform. Some functions, built-in functions that could help you. One is matrix. Is matrix will help us test to see if an input is a matrix. Is vector. Same thing, but just with a vector. And there's also is scalar. Same thing, but with a scalar. And another function that I want to look at today is the mod function, which is short for modulo. Modulo gives you the remainder of dividing one thing by a second. So let's start with is matrix. So I will close my editor window there. I will clear the workspace and clear the command window. Start fresh. Let me define a matrix, call it capital M, and maybe we'll make it 1, 2, 3, 4. There's my matrix M. And let me define a vector. Call it capital V, and we'll call it 1, 2, 3, 4. There's my vector. Remember, a vector, the definition of a vector is that it's a special matrix. A matrix in which at least one dimension is 1. So this vector is a 1 by 4. It has 1 row and 4 columns. So because it has 1 row, this is a row vector. A scalar, I'll call it little s, is just a number. Call it 1 in this case. So there's my scalar. A scalar is a special kind of vector. It's a vector in which has both dimensions 1. So this is a 1 by 1 vector. It stores one number. Okay, with those three stored in memory, let me ask the question, is matrix M? Now, if you're following this sequence of videos, previous video we showed that true is evaluated as 1 in MatLab, and false is evaluated as 0 in MatLab. So if this is true, I should get a 1. If this is false, I should get a 0. So is M a matrix? Sure, of course it is. So I hit enter, and it gives me a 1. Now let me try is vector M. So is M a vector? M is a 2 by 2 matrix. a vector has to have a dimension that is 1, either one row or one column. So no, this isn't a vector, and I get false, 0. And I can try is scalar, m, and similarly I'll get a 0 there. Let me clear the command window, display M, V, and S for you again. Now let's try is vector. Let's try V, capital V. So is matrix V. So is V a matrix? Let's check it out. It says true. So this is a matrix. Okay. What we said about vectors was that a vector is a special kind of matrix. It's a matrix, in this case, whose number of rows is 1. Okay. So yes, it is a matrix. That's why we get true. Is vector V? Yep, of course. But is V a scalar? No. A scalar is a special vector who has only one element contained in that vector. So no, we get false there. Okay, let me clear the command window, display M, V, and S for you. And let's check out S. So is matrix S. So what do you think? Is S a matrix? Yes, it is. It's a special matrix. It's a 1-by-1 matrix. Yep. Is S a vector? Yes, it is. Right? It's a special vector. It's a vector containing only one element. And is scalar. Is S a scalar? Yes, it is. Okay, so is matrix, is vector, and is scalar we can use to test the inputs coming at us. If we write a function and we expect that the input coming at us is a scalar, we can test is scalar. Let me open up my function again. That was my Newton. For example, let's say I wanted to test if m was a scalar. So I could say if is scalar m, and I'm going to test to see if it's equal to 0. And remember from the last video, you use double equals to test equality. So equals equals. So 0, if that's false, meaning it's not a scalar, then I'm going to throw an error. Mass must be a scalar. End. Okay. So let me show you how that works now. Let me clear the command window, clear the workspace. So let's give it force of 10 newtons, and let's give it a mass of 2 kilograms and 5 kilograms, whatever that means, right? So mass is a vector in this case. And let me call my function F equals my Newton, F mass. Error line 13. Mass must be a scalar. In this case, the inputs passed this test, meaning F mag was not less than 0, so it skipped this. Now, none of the components in mass were negative or 0, so it skips this. So it goes to line 12, and now it asks, is m a scalar? No, it's not. In other words, that's false. So that equals 0. So if it equals 0, then we're going to throw an error. Mass must be a scalar. Good. Last function I want to address in this lesson is the mod function. Sometimes you will need to check if something is an integer, meaning -2, -1, 0, 1, 2, 3, 4, etc. Or you might check to see if something is even or odd. The mod function can help you do that. So let's first test if a variable is even or odd. Okay, let's do that first. So let's say I have a scalar. We'll call it a equals 5. Okay. And I want to test if a is even or odd. The mod function will help me do that. So I can type help mod if I want. Let me do that. You see mod. Modulus after division. Modulus means remainder. So it requires two inputs, x and y. And x is the number that we want to divide, and y is the number that we're dividing by. So let me clear the command window. So notice if I take mod 4, comma 2, this is saying tell me the remainder after taking 4 divided by 2. No, the remainder is 0. Tell me the remainder of taking 4 divided by 1. Now the remainder is 0, right? You divide anything by 1 and the remainder is going to be 0. Tell me the remainder of taking 4 divided by 3. The remainder is 1 because you take 4, divide by 3, so it goes in once, and then you're left with 1 over. 1 left over. Tell me the remainder of 4 divided by 4. That's 0. Because 4 goes into 4 once, exactly once, with no remainder. Tell me 4 divided by 5. Well, the remainder is 4. Because 4 divided by 5, 5 does not go into 4 at all, so it's 0, remainder 4. Okay, back to the problem at hand, we have a variable a, and we want to test if that is even. So we can do mod a 2. So what will that give us in this case? Yep, it'll give us a 1. Because when I take a, which is currently 5, and I divide it by 2, I get 2 remainder 1. And if I divide anything by 2, and I get a remainder of 1, that means that thing was odd. And if I take anything and I divide it by 2, and I get a remainder of 0, that means that thing was even. So if I wanted to test for odd in this case, I could say if mod a, comma 2 equals 1. That would be my command. So this would test for odd. Right? And if I wanted to test for even, I would change that to equals 0. Again, the double equals means I'm testing for equality. Good. Let me get rid of that. You can also use mod to test if the variable is an integer. Testing for an integer is important because you might expect an integer, and it might be a row. You expect the user to input some sort of row. Maybe it's a column. Maybe you're playing Connect 4. Okay, and you ask the user for a column, and you drop a marker in the column. Well, if the user gives you 3.5, that doesn't make any sense. So you want to tell the user, hey, you got to give me an integer. All right, so based on what we just said about the mod function, do you have any ideas how you would use the mod function to test if something was an integer? Well, it's kind of tricky. We're actually going to divide by 1. So let's consider two cases. A is 5, and B is 5.256. In other words, A is an integer, and B is not. So if I divide A by 1, and I ask for the remainder, of course it's 0. 1 goes into 5 exactly 5 times, so I have a remainder of 0. But how many times does 1 go into 5.256? It goes in 5 times, but the remainder is not 0, is it? No. So let me type mod b, comma 1, hit enter, and notice I get a non-zero answer, or remainder. So if I wanted to test if something was an integer, I could say if mod of v, or whatever our variable was, comma 1 equals 0, v is an integer. Usually I'm testing if it's not an integer, because if it is not an integer, then I would want to throw an error. So in this case, remember from the previous video that tilde means not. So if mod of v, comma 1 is not equal to 0, v is not an integer. So in that case, I'd want to probably throw an error. But we don't have v defined in memory, so I won't execute that line. Alright, let me clear the workspace, clear the command window. And let's review the key points in this lesson. Okay, the first key point is that I can use the error function. To check if the inputs are as expected. We use the error function. The primary goal of input error checking is to stop the code. And we can also send a red message back to the user. That's nice too. but we want to stop the code. We want to keep any semantics errors from propagating through subsequent blocks of code. And another key point here is we are only checking, as the name suggests, the inputs. We aren't checking, for example, any intermediate calculations that we do in our code. It's expected that we code our function correctly, because we're not going to throw errors if we didn't code our function correctly. We are only checking that the things being sent to our code are correct and as expected. Okay, we can use is a scalar, is vector, is matrix. For testing dimensions. So these are just 3 new built-in functions that have become available to us. We might need them, we might not. It depends on the application. It's hard to say. But they are introduced to you in this lesson, and so now they're available to you. And we also saw the mod function. Mod function can be used to test even, odd, or for integers. We used to test for integers. The mod function requires 2 inputs. You give it x, that's the number that you are dividing, and y, that's the number by which you are dividing. And this gives you the remainder as an output